All right, so ambiguous law of sines. Basically, when we're given a side-side angle triangle and we have two sides and an angle that's outside of that, we don't know how many triangles that could create. There's a bunch of different situations. To start here, like there's a possibility if I'm given this angle A here, the adjacent side B and the opposite side A, if this side isn't long enough, like if we're just given the values, we don't know this, but I could say like, oh, angle of 42, like B is equal to 53 and A is equal to 5. Like we could be given those values, but we don't know that that actually makes a triangle. So we need to do some math to check that. There's a situation here where that A is not long enough. No matter what angle I make this one, it's going to not give me a triangle. Then there's the second possibility where the opposite side is exactly equal to the height. That's the one that gives me a right triangle and makes things really easy. But I have to actually check that. So I have to find the height first, and then I have to check, is the opposite side the same as the height? Same idea for the third case. This is what we call the ambiguous case. If the opposite side is greater than the height, but less than the adjacent side that we are given, there's two possible triangles that can be created. Meaning, like, again, this angle stays the same, angle A. This side length stays the same for B. This side length stays the same. All of those things are true, yet we get two different triangles. So in that situation, we're going to need to figure out what are those two triangles and maybe solve each of those. Again, that's when the opposite side is greater than the height, obviously longer than the height here, but less long than the adjacent side. And the last possibility is this obtuse triangle that we see here, that if the opposite side is greater than the adjacent side, we get one triangle for sure. Okay, so we're going to call this the height test, where we're going to find the height first, and then we're going to check, okay, hey, is it between the height and the adjacent side? So when we're going through this here, if you look at these two examples, they're pretty good ones, where you first have to find the height, which is in orange here on the left, by using sine of 30 equals, the height over 10, because we're kind of creating a right triangle here. Then we see that our height is about 5.45. Our opposite side, which is 6, is between the height that we just found and the adjacent side, which tells us there's two possible triangles. So we're going to do this really quick, where we're going to draw these out. We're going to sketch them. We're going to find the height, and we're going to check how many there are. So first one here, I have angle of 50. This is angle X. XY is 20, and YZ is 32. So I don't even have to do any math here to see that there's going to be one triangle, because I see that the opposite side is greater than the adjacent side. So I know for sure there's only going to be one triangle. The second one here, when I sketch this out, I got 43 for angle R. RS is 29, and ST is 23. So I see here that the opposite side is less than the adjacent side, so I have to check for the height first. So my height here, sine of 43 equals the height over 29, because that's my hypotenuse of this right triangle that I just created. I plug into a calculator 29 times sine of 43, which my height is about 19.8. So I see that my opposite side is greater than the height, but less than the adjacent side. So this is one of those times that we have two triangles. Last one here, angle L is 62 degrees. LM is 5, and MN is 4. I got to check for the height here. Height is sine of 62 equals the height over 5. I multiply 5 by both sides, so 5 times sine of 62 is 4.41. I see that my opposite side is less than my height, so there are no triangles. So that's how we use the height test to see how many there are. Once I find that there's one triangle, I can solve it. If I find out that there's no triangles, I'm done. If I find that there's two triangles, well, then that's case 3, and we have to actually solve for both triangles. So I'm going to walk us through this one here where we were just given, we found that there was 2 triangles. So we did up to this part right here. And we're just checking from there what the angle here is of my bigger triangle. So for example, right, I'm going to redraw this here. I know that there is 2 triangles. There's one of this bigger triangle, and there's like this kind of skinnier triangle here where the angle here is going to be 43, adjacent side 29, opposite side 23. Same for this one, 29 and 23. So I'm going to first start out by finding this angle here. To do that, I'm going to use the law of sines. So I'm going to say sine of this angle that I'm looking for over its side length, sine of 43 over 23. So I'm going to do, again, I walked through it right here. So I called it sine of t, but it doesn't really matter what you call it. In this case here, I'm going to multiply. Oh, I made a mistake somewhere, did I? No, I'm good. So I multiplied 29 to both sides, and then I took the inverse sine of this, and I plugged this into a calculator. So what I ended up getting was 59.31. So that's this one right here. 59.31 is that angle. But I need to figure out what this angle, let's do this in pink, this angle right here is. And to do that, I know that these 2 angles, the orange and the pink, are supplementary, meaning they add to 180. So really I just need to take 180 and subtract 59.31, which is where I get this 120.69. So again, find the angle of the larger triangle first, use the supplementary idea and subtract it from 180 to find the other angle of this. Now that you have both of those, then you can just solve for the rest of your triangles. You can use triangle sum to find the last angle, and then law of sines to find the last side.